Good day, students. Today we want to talk on arrangement of capacitors, both in series and in parallel. Let's see what's on the board. When capacitors are arranged in series, you can see them C1, C2, C3. They are arranged in series. How do you know? When current moves, this is positive terminal of this cell, and this is negative terminal. It moves from positive up. When current passes through this capacitor, pass through another capacitor, there's no division. Is that okay? It flows the same way. At that point, when capacitors are in series, you find the reciprocal of the capacitors to get your equivalent or the resultant capacitance. Is that okay? Now, when you are in series, it's opposite to the resistors. Now, when these resistors are in series, you just add them together. But when they are in parallel, when resistors are in parallel, you find the reciprocal of it. But when capacitors are in parallel, you just add them like that. You can see that as current is moving, it's moving like this. Get to this point, divide here, divide here, divide to this point, and divide. Okay, and divide. Is that okay? Divide. Under capacitors in parallel, if you just add them together, the capacitors you add them together. But under series, you find when they are in series, you find the reciprocal. It's opposite to the resistor. Okay, now let's solve this problem. Two capacitors of capacitance is 5 microfarad and 3 microfarad are connected in series, and the resulting combination is connected across 600 volts. What is the equivalent capacitance of the combination? Now let's draw it. They are in series. Let's call this one first one is 5 microfarad connected in series. Let's call this one C1. In series with another capacitor, 3 microfarad. When you are drawing capacitor, let the two hands be the same. That's C2 series with across volts supply. What is the equivalent capacitance of the combination? Now we find the equivalent. You have 1 over, because they are in series, you find the reciprocal. 1 over C equivalent equals to 1 over 5 plus 1 over 3. Leave the microfarad for now. Divided by LCM is 15. 5 in 15, 3. 3 times 1, 3. 3 in 15, 5. 5 times 1, 5. Which is 8 over 15 microfarad. When you divide it, you can't divide it for now because it's 1 over C equivalent. You now have 1 over C equivalent equals 8 over 15. Okay, now you cross multiply. You have 8C equivalent equals 15 times 1. Now divide 8C equivalent equals 15. Divide both sides by 8. By 8, 8 cancel 8. C equivalent equals 15 divided by 8. We have 1.875 microfarad, which is, and microfarad is 1.875 times 10 to the power minus 6 farad. Micro is 10 to the power minus 6. Now we have to look for the total charge in the combination. In the first part of the question. The second part is charge equals CV. And what's our charge? What's our C? 1.875 times 10 to the power minus 6. You have to convert it to this because we want to use it in the next question. You don't just use micro, leave the micro and multiply with this. You have to open it up, multiply by 600. Q now, the charge Q equals, when you press the calculator, you have 1.125 times 10 to the power minus 3 coulomb. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.